Okay, so you know that feeling, right? Want to understand something new and exciting, not just like a surface level thing, but a proper dive. Well, that's exactly what we're doing today. We're going to explore a really interesting development in AI, deep search, or ODS for short.
Exactly. And thankfully, we have a pretty detailed research paper and some supporting notes that really break down how it all works. I think it's fair to say that this is a real step forward in how we can use AI for search, especially with all these proprietary AI search tools popping up all over the place.
Yeah, I mean, we've all seen them, right? Perplexity's got their Sonar Reasoning Pro, and then there's OpenAI with their GPT-4o Search Preview. It's getting pretty crowded.
Yeah, and that's actually a big part of why ODS is so interesting. It wants to offer a strong open source alternative to those closed systems.
Right. So today we're going to try to get to the bottom of ODS, figure out how it works, what makes it unique from an academic standpoint, and understand why it's getting all this attention for how well it does on those benchmarks. We really want to emphasize the academic side of things here, the real innovations that make it special.
So right off the bat, it's important to realize that ODS actually has two main parts that work together. These are the open search tool, the open reasoning agent. And these are the two big innovations that we're going to be looking at.
ODS Open Deep Search is super adaptable, right? It can be used with all sorts of base large language models, whether they're open source projects like DeepSeek R1 and Llama 3.170B, or even closed models that you can access through an API.
Exactly. It's designed to be really flexible, so you've got a lot of choices for which LLM you want to use as the foundation. But as we mentioned, the real breakthroughs are in the open search tool and the open reasoning agent, both of which leverage the power of that base LLM.
Now, I noticed something interesting. There are actually two versions of this open reasoning agent, right? They're called ODS-V1 and ODS-V2.
Yeah, that's right. ODS v1 uses a React-based agent, while ODS-V2 uses a Codeact-based agent. We'll get into the differences between those two architectures and the reasons they were chosen a bit later. That's where a lot of the research's novelty lies.
Makes sense. And if any of you listening want to dig deeper into the technical nitty-gritty after we're done here, the open source repository is available at github.com/sentient open deep search. It's all out in the open for anyone to explore.
Yep, everything's right there. Just a quick note on terminology. When we say something like ODS v1 plus DeepSeek R1, we just mean that it's the first version of ODS, the one with the React agent, and it's using the DeepSeek R1 LLM as its brain, so to speak.
Got it. So let's dive into the first big innovation, the open search tool. It says in the paper that this tool aims to outperform those existing search engine augmented LLMs, and it wants to do that while still being scalable and open source. What are the main things that make this possible?
One of the most interesting things, academically speaking, is that the open search tool actually works in three stages: query rephrasing, retrieval, and augmentation. And each one of these stages has some really innovative techniques.
Okay, so first up is query rephrasing. Why does it need to generate multiple versions of the initial search query?
Well, it's all about understanding what the user actually means. You see, a lot of times the initial search query that someone types in can be pretty broad, and it might not really capture the specific information they're looking for. Like in their example, someone searches for how to make my internet faster. That's a pretty general question.
Right, there could be a ton of different things they could be actually trying to fix.
Exactly. So the OpenSearch tool doesn't just take that query and run with it. It actually generates a bunch of rephrased queries like how to make the Wi-Fi signal stronger, or how to increase bandwidth, or how to reduce latency. These rephrased queries try to bridge the gap between the user's broad question and the specific information they probably want.
I see. So it's casting a wider net initially, but also trying to be more precise about what the user's actually after. That makes a lot of sense for getting the most relevant information back.
Right. And according to the research, this rephrasing step is really important for both coverage, finding as much relevant information as possible, and diversity, making sure you're getting information from different sources.
Gotcha. So next comes retrieval. Once we've got these rephrased queries, how does the open search tool find the actual information?
It uses a Search Engine Results Page API, or SERP API for short, to get the initial search results for all those rephrased queries. The paper specifically mentions using serper.deb for this, but they don't just grab those little snippets of text. They use a special formatting process that's inspired by something called fresh prompt.
What's special about this formatting?
It's all about giving the language model the one that's going to process all this more context for each search result. So alongside the actual snippet, they include things like the title of the web page, the URL, a little description, and even the date if they can find it. This richer context helps the LLM understand where the information is coming from and what kind of source it is.
Right, so a random blog post would be weighted differently than a peer-reviewed article from a scientific journal, for instance.
Exactly. And this is actually another really interesting innovation. They specifically prompt the LLM to prioritize information that comes from sources known to be reliable. Things like government websites, academic institutions, and well-established research organizations, especially when there's conflicting information in the search results. This essentially builds source credibility assessment right into the retrieval process.
That's a pretty clever approach. So you're not just getting a raw list of results, you're getting them with extra context. And there's a bias built in to favor the more authoritative sources. So that brings us to augmentation. This one's optional, but it sounds like it's really useful for those more complicated searches.
Exactly. This stage is specifically designed for those queries that need a deeper dive into the information. If this option is enabled, the OpenSearch tool will actually scrape the full text of the top, say, retrieved web pages. Then it breaks up those pages into smaller chunks, creates embedding vectors for those chunks, and then uses a re-ranking system to pick out the n most relevant passages based on the initial user query.
So if those initial search results pointed to some really promising articles or papers, this step would essentially dig into those sources and pull out the most relevant parts.
Right, it's like a second layer of filtering, focusing on the most important parts of the already retrieved results. And another interesting thing is that they've implemented custom handling for websites like Wikipedia, Artsy, and PubMed, so the system can directly interact with those big knowledge bases more effectively.
Wow, okay, so that's a pretty thorough overview of the OpenSearch tool, a three-stage process that includes this smart way to refine the initial query, a retrieval system that looks at source reliability, and then this optional deep dive augmentation. And it seems specifically designed to handle academic and specialized sources really well. Now let's talk about the second big piece of the puzzle, the open reasoning agent. What do you do in the whole system?
You can think of the open reasoning agent as the conductor of the orchestra. It's responsible for figuring out what the user's query means, looking at all the contextual information that the OpenSearch tool dug up, and then deciding which tools are the best ones to use to answer the question. And of course, one of those tools is the OpenSearch tool itself.
Right, and we know there are these two versions of the agent, ODS v1 and ODS v2. Let's start with ODS v1. This would use as a React agent. What makes implementation so innovative academically?
The key innovation here is the way they've combined several different really powerful reasoning methods. They've got chain of thought reasoning, the React framework, and then dynamic few-shot learning.
Okay, so let's unpack that. We've talked about chain of thought reasoning before. That's where the AI basically has to think out loud step by step, right?
Exactly. And they're using it in a few different ways here. They've got zero-shot key where they just give the model a prompt like, let's think step by step. And they've got few-shot kati, where they actually include a few examples of reasoning chains in the prompt to help the model learn. On top of that, they're using chain of thought self-consistency, or COTI-SC, which is this really cool technique that generates multiple lines of reasoning and then picks the answer that's most consistently supported by all of them.
So it's not just reasoning one step at a time, it's exploring different ways to reason and then picking the most reliable conclusion. That sounds pretty robust. So where does the React framework come in?
React is all about combining reasoning with action. It's like a cycle. The language model thinks about the problem, then it takes some action, like using a tool, it observes the results, and then it uses that observation to think some more and figure out the next action. This back and forth process lets the model tackle those complex tasks that require it to interact with the outside world, and it does it in a more grounded and trustworthy way.
So it's not just passively thinking, it's actually interacting with its environment, in this case through the different tools it can use. And in figure 2 of the paper, they show the structure of the prompt. It goes thought, then action input, and then observation.
Yeah, that consistent structure is key. It gives the LLM a clear way to express its reasoning, define the action it wants to take along with any necessary parameters, and then process the information that comes back from that action.
Now, what about this dynamic few-shot learning? How is that different from the usual few-shot prompting techniques?
Well, dynamic few-shot learning is all about picking the best examples for each specific query. Instead of using a fixed set of examples, ODS v1 actually uses vector similarity matching to find the most relevant examples from a larger pool of available prompts. It's looking for the examples that are most semantically similar to the current query. This allows the system to tailor the learning examples to each individual problem, leading to better performance without having to use super long or complicated prompts.
So it's like picking the best study guide for each exam. Sounds pretty smart. The paper also mentioned something about a community effort to create the React prompts.
Yeah, that was a really cool initiative. They actually got people from the research community to help create the 200 React prompts that are used in the few-shot learning system. These people were given a general template for the prompts and some sample queries, but importantly, they didn't see the actual benchmark data that would be used to evaluate the system. This open collaboration brought in a lot of different reasoning strategies, which really boosted the performance of the React agent.
That's a really cool example of how a community can help push AI forward. So what specific tools does OPS v1 have to work with?
There are three main tools. First, you've got the web search tool that we already went over in detail. Then there's a mathematical processing tool that uses the Wolfram Alpha API. And finally, there's a continued thinking tool that lets the base LLM really dig deep into the query if the initial attempts weren't enough.
So if it needs to find external information, calculate something, or do some more complex reasoning, it's got the tools. So how does ODS v1 actually work in practice? What's the workflow like?
Okay, so it starts with the OpenSearch tool retrieving all the relevant information based on the user's query. That retrieved context, along with the original query, it gets passed on to the React agent. The agent then goes through that thought, action, observation cycle that we talked about until it comes up with a good answer. And just in case the React agent can't find a good enough answer, they actually use a separate Llama 3 8B model to judge the quality the system falls back to chain of thought self-consistency.
Wow, that's a lot of layers of reasoning. It even has a backup plan. The paper actually gave an example from the FRAMES benchmark, something about a poetry prize and Rupi Kaur's book, that showed how well ODS v1 reasons, especially how it used Wolfram Alpha to get a precise calculation.
Yeah, that was a great example. Both ODS and Perplexity's Sonar Reasoning Pro had a tough time with that multi-step reasoning, but ODS was smart enough to realize it needed Wolfram Alpha to calculate an age, while Perplexity just gave a wrong answer.
Okay, so we've covered ODS-v1. Now let's move on to ODS-v2, the one with the code act agent. What's the main idea behind this approach, and what makes it so interesting from an academic perspective?
The foundation of ODS-v2 and the Code Act agent is this idea called chain of code, or KOC. We know chain of thought is great for reasoning with language and understanding concepts, but it can sometimes struggle with things that require precise calculations or working with symbols. Chain of code lets the language model actually generate and execute code, or even pseudocode, to solve those specific problems.
So instead of just explaining its thought process in words, it can actually write and run code to solve parts of the problem.
Exactly. And there's actually research showing that this code-based reasoning can outperform traditional chain of thought on several different tasks, particularly those that involve calculations, algorithms, or working with structured data. CodeAct takes this idea and specifically applies it to interacting with external tools. Instead of using the typical JSON format, CodeAct generates actual Python code to work with the tools.
So what's the advantage of using code to interact with tools?
The research suggests that LLMs are actually really good at representing actions with code. Think about it. Code is a really structured and concise way to describe a sequence of actions. Plus, code inherently supports things like composition, modularization, and generalization, which makes it a much more flexible and powerful way for the agent to use tools compared to something more rigid like JSON.
It's like saying that code is a more natural language for AI to express and carry out actions. Pretty fascinating. So how does ODS-v2 use the search tool within this Code Act framework?
They've adapted the OpenSearch tool to work with something called Small Agents, which is a framework designed for customizing and distributing these intelligent agents. So the basic reasoning agent in ODS v2 is called Code Agent, and it uses Code Act principles to work with the search tool. The paper also mentions that more advanced versions of ODS v2 can actually use multiple tools and agents working together to answer even more complex queries.
So ODS v2 is pushing the limits even further, leveraging the LLM's ability to code to orchestrate these really complex interactions with external resources. Now let's look at how all of this actually performs. The paper compares ODS to other search AI systems, including those proprietary ones, and even to the base LLMs themselves. What did they find?
The results are pretty impressive when they tested ODS, especially ODS v2 with DeepSeek R1, against those closed source systems like Perplexity and OpenAI's GPT-4o Search Preview on benchmarks like SimpleQA and FRAMES. ODS was right up there with them, sometimes even better.
So this open source project is going toe-to-toe with the big players. That's huge. What were the specific numbers?
For the FRAMES benchmark, which is known for its challenging questions that involve multiple steps in complex reasoning, ODS v2 with DeepSeek R1 got an accuracy of 75.3%. That's actually a 9.7% improvement over the GPT-4o Search Preview, which is pretty significant. ODS v2 did a little bit worse on the easier SimpleQA benchmark, but the overall results really show the potential of this open source approach to compete with those top proprietary
It
systems.
wasn't just about accuracy, right? They also look at how many web searches each configuration had to do to get the answers.
Yeah, that's another really interesting part. Table 2 in the paper shows the average number of searches for different ODS configurations, and it looks like ODS is pretty smart about how it searches. The number of searches seems to depend on how powerful the base LLM is and on how good the initial search results were.
So if the base model isn't as good at reasoning, it might need to rely on the search tool more to gather information.
Exactly. They give an example in Figure 6 where ODS-V1 with Llama 3.17 actually did a second search to get a correct answer on a frames question, while Perplexity didn't do any extra searches. But then Figure 5 shows that ODS-V2 did fewer searches for the easier simple QA questions than for the tougher frames ones. So it seems like ODS can adjust its search strategy based on how difficult the task is.
That's a really clever strategy. It doesn't stick to a fixed number of searches. It adjusts based on the query and the capabilities of the system. Now, there was also that ablation study where they tested how much each part of ODS v1 actually contributed. What did they learn from that?
That study is shown in Table 4, and it really highlights how important each component is. They tested ODS v1 on a subset of simple QA and all of frames, adding in the Open Search tool, the code react reasoning, and the few-shot prompting one by one. Each addition led to a measurable improvement in performance.
So it wasn't just one amazing breakthrough, it was the combination of all these pieces working together.
That's right. For example, just setting the Open Search tool to the Llama 3.170B model on that simple QA subset jumped the accuracy from 21.2% to 82.4%. That's a big difference. Then adding in Code React and FewShot gave even more improvements. And finally, when they upgraded the base model to DeepSeek R1, the performance got even better, showing how ODS can really take advantage of those powerful LLMs.
It really is a perfect marriage of that sophisticated search tool and the advanced reasoning agent. So to wrap up our discussion, what would you say are the biggest innovations in Open Deep Search from an academic perspective?
I think there are several key takeaways here. First, you've got the Open Search tool itself with its smart query rephrasing to understand user intent, the focus on retrieving information from reliable sources, and that optional deep dive augmentation for more complex searches. Then there's the flexibility of the Open Reasoning Agent with both React and Codact options to address different kinds of information needs and leverage the strengths of different reasoning approaches. Plus, there's that dynamic few-shot learning in ODS v1, making the in-context learning more efficient and adaptable. And finally, there's the intelligent way ODS uses and combines different tools.
And of course, the big picture here is that this entire system is open source and it's performing as well as, and sometimes even better than, the best proprietary search AI systems out there.
That's exactly right. And that might be the most impactful innovation of all. By making all of this available to everyone, ODS is democratizing access to state-of-the-art search AI. That could lead to a whole lot more innovation and transparency in this incredibly important field.
Let's quickly recap our deep dive. Today, we took a close look at Open Deep Search, focusing on those two big innovations, the Open Search tool and the Open Reasoning Agent with both its React and Codact versions. We saw how these pieces work together using advanced reasoning methods and a novel approach to searching for information. And in the end, it led to some really impressive performance, even surpassing some of those leading commercial solutions on certain benchmarks.
I think you summed. And that brings us to our final thought for you, the listener. Think about what these advancements in open source AI-powered search could mean for the future. What are the implications for transparency and for being able to verify the information we get? How could this open approach lead to even more innovation and collaboration in the research community? And what are the potential benefits for society as a whole if these sophisticated tools are available to everyone?
Definitely some big questions to think about. For those of you who want to dig into the technical details, we highly recommend checking out the ODS story on GitHub and the paper itself. There's a lot more information in there.
And as you think about what we've discussed today, consider how these kinds of open source tools might change how you find information and learn new things. Could this community-driven development lead to even better, more reliable ways to explore the vast world of information that's out there?
Lots of exciting possibilities to consider. Thanks for joining us for this deep dive. We'll see you next time.